Now, the next variation that we have is the usage of the usage of the semi-supervised learning, where we have this combination, the first combination of supervised and the unsupervised learning. Here now the data set we have has have output already some dependent variable y, as you can see in the figure. So we have some classification task here, the positive and the negative. So we can like vary between these dependent variables, and it's given for only few instances of the input. So we have it in the when you have different samples. Let's say that you're having a radiologist who is annotating some of the images to have a COVID, like for the lines, to define if there is a COVID or not. And he has a lot of pictures or a lot of images to decide if it has or not. Like, let's say that we have 1,000, but he only has the time to do only 50. And what you see here is these 50 between having COVID or not, only for a few instances. Now, the semi-supervised learning paradigm comes to mix between these unsupervised and supervised approach, and it will combine the properties of both. So basic classification will be designed on the few labeled data instances. The ones that have label already will have our model from these labeled ones, and this is called the semi-supervised. And then in this section, you start with trying the model with the points that you have where the radiologists have already decided if there is a COVID or not, plus and the negative, and then comes the next step is performed where the model would be tuned up to operate without the supervision part. So we don't need now the radiologist in order to decide for the other large unlabeled data instances, and will assign them to the classes from the first step using the similarities that we have in the inputs with the points that have already occurred. Yeah? And here we apply the unsupervised part. Therefore, the second step of the semi-supervised usually is to transfer the labels to all samples through their similarity to the original labeled data. So we applied supervised in the beginning, and then we applied the unsupervised to the points that are now here, you can see in dots, in order to define the process. Yeah, usually it's used a lot in the medical images field, and the expert can label a small number of radiology scans of a specific disease, and therefore it can be like, of course, time intensive task to put all the labels for all the scans, and then comes the developed semi-supervised learning, where all will be automatically grouped to the rest scans that doesn't have any label. Now, the last paradigm is the reinforcement learning. Now, let's imagine that you have a dark room, and in this dark room, you want to move without hitting any obstacle. Okay. Now, the main task is that you start from starting point until you hit some obstacle. Yeah, and then you go back to the initial place and then restart the walking again by now having the knowledge that to avoid the obstacle that you have, and then you will detour just before the obstacle you had previously hitting. If we look at the figure here, so you have this like a dark field, and that's you trying to walk in this dark field, and the steps you do, either you move ahead and then you cross the field without having any obstacles to hit. Now, the ingredients of the reinforcement learning that are important: the agent, that's you. Yeah, it's the hypothetical entity that performs the action in the environment, the action that you're trying to do, the possible move, basically, that you can take. And then the environment, you have the dark field. The scenario, we have dark field and the agent now trying to accommodate to this environment. And the state is basically the current status that you have, and we get from the environment. The reward is the immediate return sent back from the environment in order to evaluate the last action by the agent. So if you have a step forward where you did not hit any obstacle, then you can go forward and the immediate return that you continue. Otherwise, you have to go back to the initial position in our scenario here. Yeah. And the policy is the strategy that the agent employs in order to determine the next action on the current state. We said that the naive approach was taken that to restart from the initial position if we made a mistake. So this is basically the policy. And the value is the expected long return of the current state under the policy by the different rewards that you have taken without hitting the obstacle. And here we look at the long term actually return that you get from the current state under this policy. So if we look at try to compare both reinforcement learning with the different ingredients. If you look at the right side, we have the agent, the environment, the action, the reward, the state. And if we look at the left side here, so the agent is basically you. The action you're taking is the walking, and the environment is the dark field. The reward you get is by crossing the field without hitting anything. The state is basically moving forward from one step to another. So the reinforcement is basically it's an approach, it's a paradigm that you're learning, but sequential decision making processes. Okay, the model is simply given a goal to achieve, and it learns how to achieve this goal by trial and error interaction with the environment. Reinforcement learning accomplish the machine learning in different ways from both the supervised and unsupervised learning, and it follows the cause and effect method because the developed reinforcement model learns by performing an action in the environment that would result